Bismillahirrahmanirrahim. So we are back with our another lecture in the coordination chemistry, which is the geometrical isomerism in ML6 complexes. So that actually means we have a metal and we have 6 ligands attached. So this actually means the octahedral complex. Fine. So in the last class हमने discuss ये किया था उस class में कि geometrical isomerism means when we have the molecule with similar formula, the complexes with a similar formula, but they have the different arrangement of the ligands around the central metal line. When they are adjacent to each other, हमने कहा था that's called a cis, and when they are opposite, when they are not adjacent, so they are called as a trans. Now today, in the last class में हमने discuss किया था, we talk about the ML4 complexes. So there we discussed the square planar, and now we'll talk about the octahedral complexes. So we say this is basically the octahedral complex. So this is your octahedral complex. और octahedral complex में थोड़ा सा information को ऊपर ले जाता हूँ. इसको हम designate करते हैं higher class में OH. So this is basically the point group also. So that's OH means octahedral complex. Okay. So as far as this isomerism in octahedral complexes is concerned, so we can actually do is we'll start with the first type. So हमने last में discuss किया था. हमारा जो first type होगा, so that will be first one. The octahedral complex can exist as, it can be ME4 B2 type. That means we have a metal और उसके साथ 4 ligands they are same, that A, और 2 ligands they are a different type, that is they will be B. So 2 different types of ligands, but the number is 4 plus 2, that's 6. So we'll take the example. So we have a complex cobalt complex where we have ligand ammonia where their number is 4 ammonia ligands or amine ligands and 2 chloride. This is a complex which overall bears a positive charge. So now how it forms the cis and trans isomers? It's very simple. If you have cobalt here and then 4 ligands are on the plane, fine, 4 ligands are here, so this is your 5th above the plane, this is your 6th above the plane, and then if we have arrangement like this, this is 1 ammonia ligand, this is another, and then 1 is here, then we have another here, another ligands here. These are coordinate bonds, so we have 1 chloride here left, another chloride ligand here left. So this is our square planar, these 4, and then this is basically, this is above the plane and this is below the plane. So this is your octahedral. If you see here, they're on the same side, whether above or below. So this is actually the cis. And this is these 2 ligands, they're on the same side. So this is called as the cis isomer. It's called a cis isomer. And this has a property that this molecule is violet. So this isomer is violet. So one can detect this from the color of the solution. So this is violet, or even the color of the crystal. Fine. Now we'll take the trans of this. So for the trans of this, what we'll do, we'll exchange it. That means we'll take this chloride here and this ammonia here. So we have, so you can write here. So you have a cobalt here. These are 4 at 4 corners. Fine. So this is your ammonia ligand, another ammonia, and another ammonia ligand, another ammonia ligand. So these are the 4 on the plane. So that makes your square plane type structure, and then 1 above and then 1 below. So 1 above there, now we have chloride ligand, and this is chloride ligand. So you could see that these they are on the opposite side, so they are on the opposite side. So the similar ligands on the opposite side, these two. So this is called as a trans. So it was violet, and here this is a green complex. So you could see this crystal is at green, or you could see the solution as a green. So this is one example of cis-trans isomerism in octahedral complex, ML6 complexes. For example, first type is Ma4P2 type, Ma4P2. Okay. Now we'll move to example number 2. This is example number 1. So now अब दूसरी example पे हम जाते हैं. For example, we have second example of octahedral complexes M, AA2, and we have the B2. अब देखिए AA2 मीन्स जिसे मैं लास्ट क्लास में एक लिगैंड हमने लिखा था AB2 टाइप. हमने कहा था इट इज बेसिकली इट्स अ बाइडेंटिक लिगैंड, बट उसमें जो दो डोनेटिंग साइट्स है दे आर डिफरेंट. सो हियर इट्स अ बाइडेंटिक लिगैंड, but जो साइट्स इसके पास है दे आर सेम. And then another ligand is there which is unidentate, their number is 2. So 2 2s are 4 and 2 is 6, so it's an octahedral complex. So example, cobalt complex. Then we have a bidentate ligand E and 2, that is ethylene diamine. And then we have 2 chloride ions. This is a complex ion that is charged +2. This is the cobalt complex. So this is ethylene diamine. Ethylene diamine is basically CH2, CH2, NH2, NH2. So it has 2 donating sites, both are similar. So it's a homobidentate type ligand. So this is called as ethylene diamine. Fine. Now we'll make the complex of this. How did cis-trans isomers exist for this type of complex? Now the cis isomer is concerned. So this is your cobalt. Here at the center, transition metal cobalt. So make your 4 ligands on a scar plane. So this is your, इसको हम ऐसे दिखाएंगे, this is your ethylene diamine. Fine. Chloride. Then one more chloride here. One more is here. So 4 here. So this is your complex. So you can see here ethylene diamine bidentate ligand. तो इसमें ethylene diamine का जो एक पार्ट है जो हमने वहां बनाया था, एक NH2 that's actually on this plane and one NH2 is below. So यहाँ पे both the NH2 on the same plane. So this is, since you can see here the similar ligands on the same side, so it makes it a cis isomer. Its trans is very simple. So what you do is in the trans, you keep here chlorides on the opposite side, above and below the plane, and keep the bidentate ethylene diamine here. It means you have NH2 here, NH2 here. So this is your transform. This is your cis form. So this is your cis-trans isomerism. Then we have one more project here, one more example. This is second type. So one more example you have, that is Ma3 type, third. So you have third type. Ma3B3. That means सेंट्रल मिड लाइन के पास there are two types of ligands, A के 3 होंगे और B के 3. So this is B3. So it makes a total 6 an octahedral complex. Example: cobalt, amine 3, and then chloride 3. So this is your complex octahedral of the type Ma3B3. ये बहुत ही important है और usually ये जो है the objective type exams में this type of question is asked. So now how it makes the cis and trans isomers. So in this, basically in this case we have the isomers like, so we'll make it cobalt here. Octahedral may always you place first your 4 ligands on the plane and then you check how you can place other 2. This is 4 ammonia, ammonia ligand here, place here chloride, then chloride, and then chlorine. So this is your plane. अगर आप यहाँ से इसको देख लो पहले, this is our square planar part of this octahedral complex. अब इसमें you can see 2 ligands जो ammonia के they are on the plane, one is below the plane, but then they are occupying the same faces of the octahedron. ठीक, similar on the similar side, so the faces are similar. Same is the case here. 2 chloride ligands, they are on the square planar part और one is above. So इसका मतलब है अगर इसको ऐसे देखें तो ये एक different phase पे है, it's above the plane, but then they are on the same similar side all. Fine. So basically we say that when these ligands, the similar ligands, they are on the same triangular face. So they are on the same triangular face, these 3. So plane पे 2, so they are on the same triangular face. इसमें octahedral में ऐसे होता है, ऐसे और ऐसे. So when you have similar ligands on the same triangular face, same triangular face. So this ligand, instead of showing cis, so we have a new terminology. It's called as a facial isomer. So it's called as a facial isomer. Facial, or it's called as a FAC isomer. It's a geometrical isomer instead of cis. In case of Ma3B3 complex, we use the term it's a facial isomer. So they are basically the similar ligands. They are occupying the same triangular faces of the octahedral complex. It's called a facial isomer. Now, what we'll do if we exchange one of the ligands, for example, what we'll do, so what we'll do is that we'll take one of the ligands, for example, this chloride, this ammonia will take here. So अब इसी में मैं दिखा रहा हूँ, we'll remove this chlorine, remove it here. So now you have ammonia here, and then take that chlorine here, or that chloride ion here. Now you see that one ammonia here, it is below the plane. So they are above, this is on the plane, this is above the plane. Now we don't have those on the same side kind of thing. अब ये 3 जो एक टाइप के लिगैंड थे, they are not occupying the triangle. ये 2 तो है, लेकिन तीसरा यहाँ भी इस वाले साइड में. So basically in this case, now we say that the similar ligands, they are not occupying the same side. They are not occupying the triangular face. So it's called as a mer isomer. It's called a FAC isomer. Its case now it's called as a mer isomer. Mer means it's called as the meridional. Meridional isomer. It's called as a meridional isomer rather than the trans isomer. अब basically अब ये this position जो up and down है, ये plane है हमारे पास, जो मैं plane की बात कर रहा हूँ. So ये ammonia and this chloride, this ammonia, they are now equatorial. Fine. So instead of being on the same equatorial, the same triangular plane, now some of the ligands, they're equatorial. So when this type of case arises, that these ligands, the similar ligands, they are on the equatorial plane. Now, so it's actually called as a meridional isomer. So when they are occupying the similar ligands, they are occupying the same triangular face on the same side, so of the triangular faces. So it's called as a facial isomer. And this one, it is different form, is called as a trans isomer. So trans rather than that, it's called as a meridional isomer. So we have FAC-MER isomer also existing in the octahedral complexes. Now in the last we have an example. For example, if you have another fourth type, that is MABCD. So we have 4 different EF. अब यहाँ पे example तो मैं लिखूंगा नहीं. So what I will do is that rather than writing the example, so EF, so these are 1, 2, 3, 4, 5, 6 different types of ligands. So in this case, it is better to remove that. You can actually get 15 isomers. ये थोड़ा सा मुश्किल है बनाना. 15 isomers are possible. 15 geometrical isomers. When you have midline and then 1, 2, 3, 4, 16, 6 different ligands. This is all about the geometrical isomerism in the coordination complexes which are octahedral. And the next class will move to the optical isomerism. This is all.